The MEI Art Gallery showcases the most exciting contemporary and modern art from the Middle East. Our current exhibit, Perceptible Rhythms, Alternative Temporalities, features 12 artists who explore the impact of conflict, urbanization, and the climate crisis on their environments. Open Monday through Friday from 10 to 5 p.m., the MEI Art Gallery is open to the public, or book your visit today at mei.edu/arts and culture center. From Washington, D.C., this is Middle East Focus.
Hello, and welcome to Middle East Focus, a weekly podcast on regional affairs and U.S. policy, produced by the Middle East Institute in Washington, D.C. I'm Mahmoud, Senior Fellow at MEI and the Director of the Climate and Water Program. Atmospheric rivers play an important role in the movement of water vapor through the atmosphere. It can release that water vapor as precipitation, sometimes at magnitudes capable of producing extreme weather and flooding. But what are atmospheric rivers exactly? And how do they behave in relation to current climate change? On today's episode, MEI Climate and Water Program scholar Raha Hakimdavar will be discussing with senior research scientist Amin Dezfuli the influence that atmospheric rivers have on the MENA region.
All right. Thank you, Mohammed. So atmospheric rivers can carry very large volumes of water. The impacts of these what are called rivers in the sky on coastal regions, such as along the coast of California, have been extensively studied. However, little is known about how they affect land that's far away from the oceans from our coastal areas, such as a lot of the land that we find in the Middle East. But what researchers have been looking at recently is that these rivers in the sky, or atmospheric rivers, can have really significant implications for many countries in the region, including large-scale flooding, as well as other extreme weather-related events. And one of these research scientists that's been doing a lot of work on this topic, specifically focusing on the MENA region, is Dr. Amin Dezfuli. Dr. Dezfuli is a senior research scientist at the NASA Goddard Space Flight Center and the University of Maryland, Baltimore County. Amin's research focuses on climate change and extreme events, their causes and impacts, with a particular focus on the Middle East and Africa. He uses in situ radar and satellite-based observations, as well as climate models, to explore a range of climate-related applications, such as droughts, atmospheric rivers, floods, transboundary water conflicts, health risks, dust storms, wildfires, and bird migration. I am especially excited to have this conversation with Amin today because we actually used to work together for a short time when I was at NASA Goddard as well. So, Amin, it's really nice to get a chance to learn more about some of the work and research that you've been doing on atmospheric rivers. Welcome, and thank you again for taking the time to be with us.
Yeah, of course. Thank you for the invitation and glad to be here.
Okay, well, I want to jump right in because you've been studying water and weather phenomena and impacts, specifically in the Middle East region, for some time. And you actually recently had a publication focusing on atmospheric rivers in the region that came out, I think it was last year. I kind of want to start by just setting the stage. What are the major climate extremes and their causes in the Middle East region?
So there is a range of them, and of course, like many other regions in the world, climate-related extreme events in the Middle East can have both natural and human-induced causes. From climatic perspective, these events are a result of interactions between many different factors. These factors can act across temporal and spatial scales. Some of them are regional, like the geographical features of the region, different seas and topography. And some are remote, like El Nino phenomenon that happens in the Pacific Ocean, but it can, its impact can propagate all the way from the Pacific to the MENA region. So one thing that I want to note here is that we usually tend to perceive the Middle East as a homogeneous dry land. But the region consists of a range of landscapes and climate types. So while some parts like North Africa or some parts of Saudi receive very little rainfall. We know that the annual rainfall in some other parts, like northern Iran along the Caspian Sea, can exceed 1,500 millimeters per year. And topography of the region is also very variable. So is the temperature and other climatic variables. So I think the point I'm trying to make here is that the region is pretty climatically diverse. And another thing is that when we talk about climate extremes in the Middle East, we often think of droughts, and their impacts on society, on environment, water shortage, etc. But the fact is that the region has experienced a range of natural hazards that are equally important, such as heavy floods, dust storms, recently wildfires, water quality issues, drying lakes and marshes, heat waves, just to name a few. Take floods as an example. I will give one example: the 2019 record floods in western Iran that cost about $2.5 billion, and that was an early estimate at the time. Impacts of that flood were enormous. Again, the early reports showed that 1/3 of the country's roads were damaged, 700 bridges were destroyed, and unfortunately, 76 people were killed due to the floods. The floods also forced mass emergency evacuation across the country. And that event, which was quite predictable, was caused mainly by an atmospheric river that you mentioned. And that atmospheric river brought so much moisture to the region that was equivalent to more than 150 times the aggregated flow of four major rivers in the region. That is Tigris, Euphrates, Karun, and Karkhe. So that is a lot of water that was transported only within 2 days.
Wow, that is really incredible. And, it is true that we do tend to focus a lot on kind of water scarcity challenges and the lack of water or droughts in the region. But I remember when those floods happened and they were incredibly destructive to, a lot of the infrastructure, to a lot of different sectors and to people. So, a great segue to the main topic, which is atmospheric rivers. So, can you talk a little bit about what atmospheric rivers actually are and how they contribute to more floods like what was seen in Iran?
Atmospheric rivers are relatively long and narrow bands of strong moisture transport in the atmosphere. So, think about them as like rivers in the sky, right? So these are like regions of highly concentrated moisture in the sky. Since, like in the case of 2019 floods that I mentioned, that atmospheric river was about 9,000 kilometers long and about 1,000 kilometers wide. So it originated from the equatorial Atlantic Ocean and propagated all the way from there through North Africa to Iran. So in certain conditions, such as when these atmospheric rivers encounter highlands, like the Zagros Mountains in western Iran, they rise and then their water vapor cools and condenses. So this process can result in heavy rains and in cases, floods. But atmospheric river can also contribute to flooding through another process, which is rapid snowmelt. That is caused by, the so-called rain on snow effect, and also warm air advection, because when they bring rainfall with them, so rain is warmer than ice and snow. If there is already ice and snow over the high mountains, that rain can cause that snow to melt. But also, these atmospheric rivers come in the northern hemisphere from southern latitudes to northern latitudes. So they bring warm air with them. And that warm air, when it touches, that ice and snow that's stored over the highlands, that can also create snowmelt. So all of these can be combined and then exaggerate the amount of floating water. A good example for that, again, when all these processes were involved, is the 2017 floods in northwestern Iran that also killed 48 people. That's over the Lake Urmia, that all these processes were present.
So I know you've talked a bit about the impacts and the events in Iran, but kind of across the region, how prevalent are atmospheric rivers across the entire region? Is that something that you've also looked at?
So yeah, generally we get about up to like 30 atmospheric rivers in the entire MENA region annually. And these can account for up to 50% of total heavy precipitation, in, again, countries like Iran. So the thing is, we see them more in Iran because of the specific location of mountains, that's Zagros Mountains, but also over Iraq and Turkey, that's where the extension of the mountain range goes. So we see the impact of atmospheric rivers or the precipitation caused by atmospheric rivers over parts of Iraq and eastern Turkey as well.
And has there been any change with climate change? Have we seen an impact on the prevalence or the intensity of atmospheric rivers?
I haven't specifically looked at the climate change in the past to see the changes, and that's actually one of the things that should be done. Like you said, there are just a few studies over the Middle East, and that's one of the things that I hope one would look at it. But in terms of the future projection of climate change and the impacts on atmospheric rivers, there are a couple of studies that they either look at the global scale or just specifically the Middle East. And so we know that with the global warming, air temperature will increase, and with that, the moisture content of atmosphere will also increase due to more evaporation from the oceans, and that extra moisture, some or most studies have shown that will result in more intense atmospheric rivers in the future, and their frequency at the global scale is also projected to generally increase. And some parts of the Middle East, like the Lake Urmia basin in Iran, follow that trend. But having more intense atmospheric rivers doesn't necessarily mean getting more rainfall. In fact, total precipitation may even slightly decrease over that region, I mean Lake Urmia. So this is important because it implies that both droughts and floods may become more frequent in some regions. So there is evidence for that, at least based on a couple of extreme cases that I have studied: the 2019 record floods in western Iran and the 2017 event in northwestern Iran that I mentioned. And coincidentally, both were caused by atmospheric rivers. So while the first one, the 2019 event, happened during a historical wet season, the latter occurred during a relatively dry season. And this contrast suggests that individual extreme flood events can happen in seasons with both above normal precipitation conditions or below normal conditions.
And so I have a question about our ability from a science perspective or even from an operational perspective. How easy are these atmospheric rivers to predict?
Like many other weather phenomena, atmospheric rivers can be reasonably well forecasted up to 5 to 7 days in advance. And at least that's what I have found by looking at our weather model at NASA. And so that's where we stand currently. And that lead time is, I think, quite sufficient for flood management but of course, if we have a good early warning system. But there are also efforts to extend that lead time to, a few weeks and beyond, but under certain conditions.
All right, now you see where I'm getting at. I'm, thinking about the fact that we have these rivers in the sky. So both it's a challenge from a flooding perspective, but if you can couple that with your kind of predictive capabilities, then I'm wondering, is it also an opportunity? And kind of along the lines of, are there ways that we can manage these atmospheric rivers so that we can also benefit from the water that is becoming available rather than kind of seeing it run off as floodwaters?
Yes, absolutely. Of course, it depends. So atmospheric rivers can be beneficial or hazardous, right? Depending on their intensity and duration. So by intensity, I mean how much they would rain, certain time period, like, per hour. And duration, by that, I mean how long they stay over the same spot. So actually, recently, a classification system similar to what we have been using for hurricanes has been developed to make that determination. They introduce a category 1 to 5 based on intensity and duration of atmospheric rivers. So based on that system, for example, the 2017 atmospheric river in Iran that I mentioned is classified as category 3, and that represents balance of beneficial and hazardous. So the hazard, of course, and like you said, comes from damage caused by floods, but it also, that case, positively contributed to restoration of the drying Lake Urmia, which, that water was very much needed, right? So for certain categories, these atmospheric rivers Of course, if we are able to manage the rainfall and use it efficiently, can be potentially beneficial, for the region that we very well know that suffers from water shortage. But if it goes beyond some category, like if it's category 5, if I just want to use that terminology, sometimes it's too much, like the 2019 case, that there is too much water, that there will be some floods. But of course, again, if you have a good management system and a good early warning system, you can mitigate the impacts.
That's really interesting. And are there examples in other countries around the world where they are successfully managing atmospheric rivers?
Yes, I think the West Coast United States would be the best example, and that is one of the areas most affected by atmospheric rivers and most studied. I think it's the region that's most studied, in terms of atmospheric rivers. They have done a few things. They have launched some field campaigns to better monitor and understand the behavior of atmospheric rivers, and of course, their effort focuses on California. And then they also have developed a regional weather prediction model that is customized to predict atmospheric rivers and their associated extreme precipitation in California. So that knowledge has been used then into their early warning system to better inform the decision makers. So one thing interesting is here is that actually these two regions, I mean, Western US and Iran, have several similarities in terms of climatic and geographical features. For example, both regions have a southeast northwest oriented mountain range, that is Zagros Mountains in the Middle East and Sierra Nevada in the US. Also, existence of a fertile plain located just to the west side of the mountains is another similarity. That is, Fertile Crescent in the Middle East and Central Valley in California. And their latitudinal extension is quite comparable. And the topic of today, atmospheric rivers have a strong contribution to floods in general, to water resources in both regions. And another phenomenon, low-level barrier jet, exists in both regions. So in the Middle East, that's called Zagros barrier jet, that we have shown that it plays an important role in interannual variability of rainfall in headwaters of the Tigris-Euphrates basin. And of course, despite these similarities, their main difference is distance from the ocean. So to get back to your main question, so I think in the MENA region, we have the potential to also develop a customized weather prediction model for the region if we are willing to designate the resources for that. But in terms of field campaigns, that could be a bit challenging, because if you really want to use some aircrafts to observe within the entire corridor of the atmospheric river, which these can go all the way or start from the North Africa. So there will be several countries involved. So from Egypt, Jordan, Lebanon, Israel, Syria, Iraq, and then Iran and Turkey. A coordinated effort, a campaign to make observation within that region could be a little bit tricky, I guess, at least at the current time.
Yeah, that sounds quite complicated to try to implement. So then related to that, how much can we study and learn and predict these phenomena using space-based data, like satellites coupled with models versus trying to do an multi-country aircraft campaign?
So what I have used is what's called reanalysis data. That the NASA product for that is called MERA 2, and there are European have their own version, and also NOAA. That product is a four-dimensional observation of the Earth, global. And by four-dimensional, I mean X, Y, Z, the location and also time of all the atmospheric variables. So that also assimilates, of course, satellite observations, but wherever, and also ground-based observations wherever we have, or any kind of observation that we can gather. And then there are, of course, a lot of gaps, both in time and space, and those gaps are filled with a physical-based model. So that would give us a sort of a complete picture of the Earth, and then we can use that to understand, this phenomena. Then for the same model, the same but recently a more updated version of that will be used for making the predictions.
That's really interesting. And it sounds like there are many things that could be done with the data that we easily have access to and some of the methods that you and your team have developed and others. But I really, appreciate that you laid out some of the future opportunities for research and some of those gaps. So that maybe in the future, it may be possible for us to do some of the airborne and ground campaigns to better understand the atmospheric rivers. So, the next question related to that is besides what we've already talked about, where do you see the future research directions and kind of the biggest gaps and opportunities on this topic specific to the MENA region?
So I think our knowledge about both mechanisms and impacts of this phenomenon over the MENA region is really limited to just several studies that were published in the past few years. And there's much more to learn. First, I think we need to learn more about another phenomenon or related phenomenon that I didn't talk about it yet. It's called dusty atmospheric rivers. So what I mean by dusty atmospheric rivers, these are atmospheric rivers that, in addition to large amounts of water vapor, they can also carry abnormally high loads of dust aerosols. And this feature is specific to the Middle East and North Africa, that we know, some of the world's biggest dust sources are located in that region and along the pathways of these atmospheric rivers. So why is it important, the dusty atmospheric rivers? Because expansion of dry lands in Iraq and Syria, partly caused by the GOP initiative in Turkey, have resulted in some emerging dust sources in the region. And climate models, the global climate models that make projections for the 21st century, towards the end of for the whole 21st century, have projected that some of the favorable conditions for dust storms may be exacerbated in the future in the region. And this has different implications. Of course, when we talk about dust and dust storms, the first thing that comes to mind is its impacts on humans' health, right? And also travel restrictions due to low visibility. But there are other impacts that may be less obvious to us. For example, armed groups like ISIS have exploited the low visibility during dust storms to facilitate their attacks in Iraq. That's been shown. So accurate prediction of dust storms can have implications for regional security and beyond. And a different aspect of this issue is the impact of dust aerosols on cloud and precipitation formation. And that is an emerging topic too that my colleagues and I at NASA have been recently working on it, for the MENA region. So essentially, dust aerosols embedded in the atmospheric rivers can potentially impact the amount of precipitation through microphysical processes. So I'm reluctant to say increase or decrease because it could go either way depending on what we find. But the hypothesis at the moment is that it may increase the precipitation, the dust within the dusty atmospheric rivers. And let's not forget the effect of dust storms on domestic human migration due to deteriorated health conditions. We know that climate-related migration has happened in the region, will get even worse in the future for different reasons. Droughts and water shortage, energy shortage, a lot of things. But dust and the associated health conditions is another reason for exacerbate that human migration within the region. So beside that, I think we need to improve our forecasts with lead times that are longer than 7 to 10 days of the deterministic weather forecast. So because that's limited due to chaotic nature of weather, so we cannot go beyond 7 to 10 days or so. So if we can do that, go beyond, let's say, 2 weeks or so, that would be very useful for water resources management, right? And one way to do that is to, I think, develop hybrid dynamical statistical approaches that would exploit the capabilities of both physical-based models, that we use for weather prediction, and also mathematical techniques such as machine learning algorithms that are getting very trendy these days. And the other thing is, of course, improving the observational network. So I mentioned, I know that it could be tricky, those aircraft campaigns, but we can improve our radar network, the weather radar network in each country, separately, and that would help, both our early warning system and also weather predictions. But even if we completely understand the physics, and if we do all of these things and we understand the physics of this phenomenon and we are able to predict it very accurately, I think the job is not complete yet unless we incorporate that knowledge into decision-making frameworks and also early warning systems, because that would help us to reduce the adverse impacts of these extreme events. So, after all, science should serve the people and ecosystems.
Beautifully said, and absolutely agree. Thank you for identifying so many different areas of research that are very rich and kind of, I mean, we're really at the very beginning of learning a lot about these topics. So I think it's a great opportunity for others to also take on this sort of research, and absolutely on the connection with the decision making. So important, and really mentioned so many things, from human health, public health, to regional and national security concerns, to the risk of disasters. There's just so many things that can really be done here, from studying atmospheric rivers and also the dusty atmospheric rivers, which I was happy to learn more about. So this has been fascinating. I mean, thank you so much for sharing, some of your knowledge and a bit of your research, and really bringing to light atmospheric rivers and how they impact the MENA region, and how we can anticipate to, potentially have more impacts in the future. And, I really hope that we hear more about these phenomena, that we also are motivating some decision-making processes to come about, so that we are able to take advantage of all the great science, at the same time improving the science and really helping us respond and manage much better to these weather systems. Thank you again, and I think that's it, Mohammed.
Yeah, thank you for the opportunity.
And that concludes this week's episode. Thank you to our listeners for tuning in, and to our production team for their work on this episode. For more information on topics like this, you can follow all of MEI's coverage of climate and water on our website at www.mei.edu. You can subscribe to Middle East Focus on Spotify, Apple Podcasts, and other podcast providers. And you can follow MEI on Twitter and YouTube, and subscribe to our email newsletters for the latest analysis and information on upcoming events. I'm Mahmoud. We will see you all next week.
This has been a presentation of the Middle East Institute. To support MEI's programs and podcasts, please donate at www.mei.edu. Thank you for your support.